Mr. Kennedy.
Yes, sir.
Yeah, we're ready.
All righty, I'm going to share my screen.
Okay.
Can y'all see that?
Yep. Well, yes.
Cole, can you turn that up?
That's as loud as it'll go. Can you hear it?
Nope. All right, go ahead and unshare that and I'll share it for you.
Yeah. Should be stopped.
It is. And let's go like this. Share screen. Let me know if you see it. Y'all see that?
Yes, sir.
Okay, let's try a little. Can you hear it?
Yes, sir.
Yep. And just to give you guys a heads up, I'm going to be taking notes here because this is a later on, not too far away from now, question that we're going to give you guys is what's the setup and procedure for grounding an overhead line. So I'll be taking notes on this also. If you take notes, probably help out too.
Techniques portrayed in this video comply with Osha 1910.269N, and the equipment shown meets or exceeds ASTM standard F855. Whenever preparing for any maintenance on a de-energized line, the first order of business is always temporary grounding. And that begins with laying out all the proper tools. This is best accomplished by using a tarp to keep those loose pieces organized and clean.
So I can pretty much guarantee you, we're not going to take the time. Is that your guy, B? We're not going to sit out here for hours on end laying out our tools. This is more of a Hubble demonstration, and this is pretty much all Hubble equipment out here. Usually all of this stuff is just stored on the truck. I mean, your hand line's stored on the truck, your grounding jumpers right here stored in the truck, the ground rod, screw down ground rod here on the left hand side, that's temporary. And of course the sticks we have in the bin. You're just going to pull this stuff off the truck as you need it. This tarp and layout on a beautiful day in the sunshine is not really realistic.
A tool rack for the long items keeps them high and dry too, as well as within easy reach. Now, starting from the ground up, first, the temporary ground rod screws into the soil, at least 15 feet from the pole.
Okay, so the first thing you do is install a temporary ground rod. And the thing right out here at the end right here has got a corkscrew screw in. and then a copper ground rod and a handle, T-bar handle, so you can just manually put this thing down in the ground. You also got to watch where you're going as far as depth. You want to get this thing down as deep as possible.
The spiral threads pull the 6-foot copper-clad rod into the earth for full-length contact as a low-resistance ground. This now makes the bronze T-handle a good attachment point for connecting our first grounding set clamp. To make sure it's tight, a screwdriver may be used through the I-screw. Next, the groundman places safety cones around the ground rod as a warning barrier for other workers and the public. Next, he uncoils the grounding set attached to the rod and prepares to set up the clamp on the free end of the cable.
Okay, he does something specific there. He really does give an explanation for. He installs the ground clamp onto the ground rod, and he says in a sentence, what does he say in the next sentence? It's vitally important that you do it.
Around the ground rod as a warning barrier for other workers and the public. Next, he uncoils the grounding set attached.
Okay, what was he doing?
Safety.
Okay, safety cones are fine. I mean, that's fine. But he says something in the sentence right here.
Who pulls it?
The workers and the public. Next, he uncoils the grounding set attached to the rod and
Okay, so why do we not want a coil in our grounding jumper right there?
It makes a magnetic field.
Right, right. Exactly.
Strength proven.
Good answer. Good answer. Yeah, it makes a magnetic field right there, and it'll actually intensify the amount of amps that go through it if you do have a fault on the line. So you want to, even if you have to stretch it out and back down, but you don't want any coil in it once you've got it up to the lineman.
prepares to set up the clamp on the free end of the cable. But first, he checks an auto-ranging voltage indicator for operable condition with a separate instrument tester.
Okay, this is a Hubble chance video. Professor V can attest to this. This is probably what, a $500–600 tool?
Yeah.
Yeah, this is top of the line here, guys. It does a whole bunch as far as line testing. Remember, you cannot ground a line until you test it first. You got to test it to make sure there's no presence of voltage before you ground it. What we use out there in the field is what they call a tick tracer or a hot horn. Those are about $40. Not to slack off on safety. They work just as well, and when you bring it in close proximity to the line, they just give off a loud tone. So just a disclaimer here. This does the same thing, but this is a Cadillac.
Yeah.
Must be done prior to every use. Then the lineman tests each phase to make sure the line has been cleared. Notice that the unit is mounted on the hot stick to maintain proper clearance as though the line were energized. Sent back down to the groundman, the auto-ranging voltage indicator is rechecked to confirm that it was operating properly. He again uses a separate tester to activate the auto-ranging voltage indicator. Notice how it sequences through a series of all display ranges, verifying its full functionality. Next, a tubular wire brush mounted on a universal stick thoroughly cleans all conductors.
Okay, this is also very, very important, and a lot of linemen kind of, what would you say? I don't want to say avoid, but just don't really consider this part of installing grounds and really any kind of connection that you're going to put on a conductor, either temporary or permanent, is wire brushing.
Yep.
And actually, it's just an attachment that you put on the stick. And inside that cylinder right there, you can put it over the conductor. They're just wire bristles that are inside. They do recommend this, even if it's brand new conductor that you put up in the air, wire brush it. Now, why do we wire brush it? What's the electrical situation we're trying to get away from? And not
Make sure you get a good connection.
good connection, low resistance. We don't want any resistance in that connection right there. So if we do have a fault on the line, or we do have a problem on the line, and it does become energized, we have very low resistance right there. We want it to flow through to the grounds as quickly as possible. Professor V?
Yes, sir. And I think they kind of skipped an important step concerning cleaning your conductors. They make us clean the inside of the head on the grounds, as well as when we screwed down that ground rod, we would have had to wire brush that screw in ground connection as well.
Oh, wow. Okay. Yeah. Didn't even
Yeah.
consider that. So, when he connected the clamp to it, correct?
Correct.
Okay. Do you ever have anybody that takes what do you call those? It's like a, one that you go inside out of pipe with and actually go inside the ground with it?
Exactly.
Okay.
Around ground, yep.
I got you.
Brush.
Gotcha. Thank you.
Yep.
At the places, grounding clamps will go later. This is absolutely essential. It removes oxides and contaminants, so the grounding clamps
You know, it might look kind of lame right there the way he's doing it, but it does work.
Yeah.
Those wire bristles that are inside that brush there are very, very stiff.
can make good connections. Next, back down below the system neutral, a grounding cluster bar attaches to the pole with a chain binder. A wheel tightener cinches the chain to secure the cluster bar in the best position. Now the free end of the cable attached to the ground rod comes up and is clamped tight on the bar. Then another complete grounding cable set attaches to the cluster bar. With a grip ball clamp stick, he connects.
Okay, there was a little bit of something going on before, and when he installed the cluster mount or the cluster bar around the pole, it was real close to the neutral. And he actually had to move it because what happens here is you have to stand inside a zone. And I'll show you right
to
here.
secure the cluster bar in the best position. Now the free end of the cable attached to the ground rod comes up and is clamped tight on the bar. Then another complete grounding cable set attaches to the cluster bar.
So that's the cable that's going down to the ground rod that he's already installed. And he installs another set. This is one set, both ends attached to the cluster bar. And he's just, one does have to remain. This one does have to remain. But the other one, he's just putting up here so he can have it holding. You don't want your jumpers to be sitting way down or sagging way down the pole right there. Now you notice in the next part,
With a grip ball,
he had it installed way up here to start. Okay. Then he's already moved it. I guess they kind of just edited the video. He's moved it to where it's below his feet, and that is correct. You need to be, as far as grounding or after you've got it grounded, working on the pole inside this zone. From the grounding cluster to the primary wires. And that's because you will remain at the same potential. What about his hand line, guys? Is that where a hand line goes?
No.
No, you don't hang a hand line on a conductor.
clamp stick, he connects the other clamp of that set on the system neutral. Now, he'll finish connecting the next set from where he had hung it on the neutral in the place he cleaned earlier by wire brushing.
So he's taken one from the ground rod to the cluster. He's taken another one from the cluster to the neutral. And now he has another set, one connected to the neutral, and he's getting ready to go to the primary conductors with it.
This grounding set now bridges from the neutral to an outside phase conductor. Always
It doesn't matter which conductor he starts with.
Yes.
Why?
You always work left to right.
I mean, that's good to keep it right in your mind. Anybody who said yes?
That is.
Okay, why? I know why.
Go ahead.
You always work the conductor that's closest to you first. That's the one in the closest proximity to you.
Right.
Okay.
Yep.
Two is you'll see a step process that goes on here, and whoever said left to right, it keeps the step processes right. And you'll notice this when the video goes along.
always clamping on the area cleaned by wire brushing.
It is okay to hang your stick on a conductor. It's actually got a hook in it to be able to do that. Okay, so you'll notice on the next set of jumpers he's preparing right here, he doesn't go to the ungrounded phase, back to the grounded phase. Which phase does he start at? This phase is already grounded. You start at the grounded phase and then go to the phase you're going to ground. There is a safety reason behind this. Just in case, if you had put your set of grounds over here and you unclamped this one side and it got out of control and you dropped it, there's a potential for that thing to be energized and you don't want it to be waving around. If you install it on the grounded side first and it came out of your stick or you had a problem with it, it would still be a grounded jumper.
Yeah.
That's why you go from the grounded conductor, and you'll see the steps, grounded conductor to grounded conductor. You're going to go grounded conductor to the next conductor, and on and on.
Next, he uses a third grounding set to connect the first phase to the center phase. And finally, he completes the last link by connecting the center phase to the other outside phase conductor. The 5 grounding sets, from the ground rod to the cluster bar to the neutral and all 3 phases, now join together in one grounded circuit. With the grounds applied at a pole 1 span from the worksite, we move to the pole 1 span away from the worksite in the other direction.
Okay, this is a point of controversy, and you'll see different companies doing different things here. The previous part where you saw where he had put this set of grounds, and this is the procedure that Santee Cooper uses. If you're going to be working on that structure, that's what they call single point grounding. Even though you got 3 phases, the neutral, and you're going to ground, you're only using 1 ground rod as a single point for grounding the conductor that you're working on. He goes later into the video to say,
1 span away from the worksite in
he goes 1 span away. I got lucky on that one. Goes 1 span away from the worksite, and he installs another set of grounds. Now, Professor V, what was your practices at Duke?
Normally on source side, we grounded just like what he did. If you know, if you're climbing, if you climbing, then you'd go down, like I said, and get down another span and ground again. If you're in the bucket, if you're just working on 1 phase, then you have to go down and you'd only have to put a ground on the phase that you were working on.
Gotcha, gotcha. So when he gets done here, we'll go through the video.
The other direction. He repeats the procedure in the same order here. Again, it's from ground rod to cluster bar to neutral to the 3 phases. This establishes what's known as dual point grounding.
All right, there you go. He's just said a dual point grounding. To whereas if you've got a set of grounds and you saw the pole on the right-hand side of here, he's skipping a pole.
For the worksite, the pole in the middle.
And he's got a set of grounds on the left-hand side. You are allowed to work anywhere inside this zone. All right, between this set of grounds and the next set of grounds on the right-hand side. We don't do that. We use what they call single point grounding, because between this ground rod, and then this is through investigation and study, between this ground rod and the ground rod at the other end, there is a difference in potential. Even though they're both ground rods in the ground, there's still resistance in the earth. So that's why we used single point grounding. Now, when I say single point grounding, can one man go up the pole here and work on this pole inside the zone, and another man go up inside this zone here and work inside the zone? Is that legal? Between the cluster mount and the top of the pole? I'm going to answer that for you. It's yes, that's fine. Each lineman is using a point of single point grounding, but I cannot put a person on this structure to work on it. You're going to have to take that set of grounds and move it down to here for him to work inside that single point zone. A lot of work, isn't it?
Grounding at the worksite begins with a cluster bar. The temporary ground he's installing here at the center pole, the actual worksite, is known as a personal ground. It begins with the pole, which must be considered conductive itself, and connects from the cluster bar to one of the phase conductors. The personal ground forms a fault circuit path from the phase down the pole and thereby creates a zone of equalized potential above the cluster bar. Now he's protected to perform the maintenance this service call required, protected by a personal ground here, plus dual point grounds at the 2 adjacent poles.
See, that's gets really complicated in the process right there. So he does go to the center pole and he puts one ground on to work inside the equal potential zone. We only are going to install 3 sets per, the full set per pole per climber. So you'll see there's just a lot of activity going on with it right there. We're not going to install the 2 outside sets, both left and right, if we have to work on the center. If we need to work on that center structure, we're just going to install the full set right there and work on that structure by itself. One thing he does say, and he said it multiple times right here, you got to work inside the zone. The cluster mount right here, ground cluster mount, cannot be above your feet. It's got to be below your feet.
Now he's protected to perform the maintenance this service call required, protected by a personal ground here, plus dual point grounds at the 2 adjacent poles. On a system with a neutral too small to carry available fault.
Okay, so he goes into fault current loads and all this kind of stuff. I want to get to one part of the video here. Where was it at? Okay, after all of this and going through the entire video of what's going on, what's the major malfunction that's going on here? What's the problem with the guy installing the grounds? What piece of protective equipment is he not wearing?
You don't have the super
Doesn't have a
squeeze.
butt strap on.
Oh, this is 2002.
He's not got rubber gloves.
There you go. Thank you very much. It's not considered de-energized until you got it grounded. So rubber gloves are required to be worn. Rubber gloves are required to be worn until you've gotten all 3 phases grounded. Now, once all 3 phases have been grounded through the process, then you can take your rubber gloves off. So even after testing, You've got to wear your rubber gloves during the process of grounding. After the process of grounding is complete, you can take your rubber gloves off and then go to leather gloves. Is that the same as you, Professor V? You must have had to step away. Okay. Rubber gloves must be worn at all times until all conductors on the structure are grounded. Any questions there? All right, I'm going to unshare. Which leads us right into the book of where we're at today. And I'm going to skip up to one part and then come back to another part. So we're back in the book right here as far as the guidebook for cablemen and linemen. And I am on page 11. Rubber gloves as personal protective equipment. All right. Rubber gloves and sleeves can be used as tools for carrying out hotline work or as personal protective equipment. Wearing rubber gloves as backup protection when working in the vicinity of energized circuits has the same function as a hard hat, in that equipment provides backup protection if something goes wrong. In some jurisdictions, rubber gloves used as personal protective equipment are referred to as truck gloves. And because they are used to set poles and other things, they are not used as tools for hotline work. Okay. Rubber gloves, gentlemen, out there in the world, they are the one piece of safety item that you have in your supply right there that you need to take extra care of. And they are considered the barrier between you and everything that is energized. Now, we talked about a little bit about this before. When we get, excuse me, a brand new line truck or a brand new bucket truck, is there writing inside the manual that you get with that truck that says you are fully insulated if you come in contact with an energized conductor? Any guesses? No. They're not even going to put that information, even though you have 100,000 volts per foot on anything that is fiberglass. They're actually going to put in the book, rubber gloves must be worn while working energized conductors. They're not even going to say you have a protection up to 400,000 kV. It's not going to be in there because they don't have really control over the fleet that you've got. Is it contaminated? Do you have cracks in the boom or anything like that? So the protection that you're going to have on to prevent you from being energized by any type of conductor is your rubber gloves. So rubber gloves must be worn at all times. And Professor V came back here. He could probably go on the policy of Duke. We'll talk about these in just a moment here in the list downstairs. I'll give you a case of Hurricane Sandy. We went up to Hurricane Sandy and their policy was you had to wear your rubber gloves and sleeves 24/7. If you were walking on, unless you were driving, if you were walking on the ground down the street, rubber gloves and rubber sleeves were required. And it was bad. When it got down to 20 degrees that one day, it was kind of good because it kept you warm. But on the other days, it was bad. They required them all of the time. Professor V, as far as you're concerned, the steps 1, 2, 3, and 4 in the book, are those pretty much the steps that you followed at Duke?
Yes, sir.
Okay. So we'll talk through these steps right here. Step 1, and you guys are going to need to know these, the ground to ground rule. Rubber gloves shall, and I like the way, not should, shall be worn continuously while working on any structure carrying energized conductors. Do they refer to any kinds of voltages?
No.
Guys, if it's got 120 volts on a pole, say it's feeding a light, you got to put your rubber gloves on while you're climbing up and while you're climbing back down. Any kind of pole that you're climbing that has an energized conductor attached to it, rubber gloves must be worn. This is in climbing, ground to ground. Cradle to cradle. Rubber gloves shall be worn from the time a bucket truck boom leaves its cradle until it returns back into its cradle. Now, I know me back in the old days, I used to jump in the bucket truck, put all my safety harness on and my lanyard, and have my leather gloves, and I'd drive up the bucket up to where the work was at. Then I'd swap out to rubber gloves. Okay, as soon as you got close to the work that needed to be done, then you put on your rubber gloves. That is not allowed anymore. As soon as you step in the bucket and you get ready to raise that boom out of the cradle, you got to have your rubber gloves on, and you can't take them off until you have the bucket recradled. 3, extended reach rule. Rubber gloves shall be worn anytime a worker and the length of any non-insulated tool being used are able to contact an energized conductor. The extended reach is considered to be 5 feet, 1.5 meters, and is called a 5-foot rule in some jurisdictions.
That's right.
Now, we kind of went a little bit above and beyond, and this is Santee Cooper tool also. We considered any kind of tool, insulated or not.
Mm-hmm.
So what do they mean by the 5-foot rule as far as insulated or non-insulated tools? Can you give me an example of some of the tools that you've seen out in the field that have not been insulated?
Adjustable wrench.
Adjustable wrench, okay. What about that machine that we're compressing connections with?
Crimper.
Yeah, the crimper, the MD6. So we took it into consideration that any tool, even a stick that you had in your hands, you had to wear your rubber gloves with, as far as distribution is concerned, if you were within 5 feet of the conductor. Now, they're not really saying too much about, well, what are you doing in underground situations? We're going to get to this in just a moment. Really, rubber gloves, if you're coming up on any kind of energized equipment, rubber gloves must be worn all the times. And it really has a lot to do in consideration. I know some of you have fallen down before. What do you do when you fall down? You put your hands out to catch yourself, right?
Mm-hmm.
Yeah. So they want to also consider, well, what if I trip or I step into a hole or something and I fall over close to what's energized? You want to have your rubber gloves on in those situations too. Anything else on the extended reach rule, Professor V, that you've got from Duke?
That same rule, same 5-foot rule. If you could reach out and with your hands out with the tool in your hand, you know, you had to have that cover right there.
Yeah.
5-foot rule.
Okay. And the lock to lock rule. Rubber gloves shall be worn when a vault or cabinet with an energized cable is open and shall be worn continuously until the vault or cabinet is locked. Now, we gave this a little bit of latitude right here, and don't think we were taking shortcuts. This includes pad mounted transformers that are on the ground, enclosures, both secondary and primary. Really, any kind of piece of equipment that's on the ground, that's underground, you had to wear rubber gloves. Now, we allowed the employee to take the lock off with a key and regular gloves, and they have what they call a star bolt connection in there. Now, once he started taking the star bolt connection that attaches it to the transformer or whatever piece of equipment that you're using, once he takes that star bolt out, he must have his rubber gloves on.
Right.
So that's any voltage. Once again, there's no voltage range that's going on there. Any voltage from 120 up to all the distribution primary voltages.
Right.
Okay. Anything you'd like to add there as far as the 4 rubber glove rules, Professor V?
That's the ones we had to abide by, every single one. You know, that those rules get real serious when that was some I can't remember exactly what the term was that Duke used, but that was a rule that was a fire and offense. If you broke any one of these 4 rules, you just blatantly broke them, and they caught you without your rubber gloves in those situations, and that was a see you rule. You know, you don't get a second chance. That's a life-threatening rule there.
Yeah.
You know.
The merit that goes into and the attention that goes into wearing your rubber gloves, because that is your personal barrier between you
Yep.
and anything is energized, is taken very seriously.
Yeah.
Yeah, and then we'll talk about, you know, taking care of your rubber gloves and whatnot. But yeah, that's really something that they, and our company did the same thing. They took a lot of weight into, I mean, you just cannot, and it goes back to the video we just saw. I mean, you got a lineman up there and really, hold on one second.
For other workers and the public. Next, he uncoils the grounding set attached to the rod and prepares to set up the clamp on the front.
Okay. I see the guy that's climbing the pole, correct? And this is the first part of the video. All right, has he tested it yet? Nope. All right. So you have to assume, well, there's no grounds on it, even after you test it. So you have to assume that the conductors that are on this pole are energized. Is he wearing rubber gloves? No, he's not. He didn't wear them the entire video. What rule is he breaking as far as the list is concerned? Anybody? One, the ground to ground rule. He doesn't have his rubber gloves on. And I mean to tell you, like Professor V said, I mean, that's termination.
Yep.
That's a termination offense right there. So you can go by, baby. There's nothing on the video. So you know, you got to have your rubber gloves on when you climb a pole as soon as you start to climb it. All right. Okay, it's about 9:40 right now. Let's take about 15. I think Professor V, you got the roll, don't you?
I'm rolling. Yeah, I'm getting out of here.
Okay, we'll take about 15 minutes and we'll come back. Let's everybody take a break. All right, not today. No quiz today, but for tomorrow, we're going to have a quiz out there and you guys are going to have to list the step procedure as far as concerning grounding a three-phase overhead line. So I'm going to share my screen here. And we will actually go through the step processes of the that are going on. And then you'll have these for your notes. You'll be able to refer back to the video as far as that is concerned for the quiz that's tomorrow. It's not going to be multiple choice. You're just going to have to list all these. To be all encompassing here on the top, I have included just wire brush all connection points, including the ground jumper clamps. So we're not going to go install a ground rod, then brush it. We're not going to install a clamp, then brush it. We're not going to install, you know, brush the primary or whatever. It's just going to be all encompassing. So the first step in his process.
Free end of the cable. But first, he checks an auto-ranging voltage indicator for operable condition with a separate instrument tester, as must be done prior to every use. Then the lineman tests each phase to make sure the line has been cleared.
Okay, so the first step in this process right here is we're going to have to test each phase. Test each phase with line tester. I'm just going to leave that open a little bit. Now there's different types out there. You have the tick tracer, which makes a sound. You have this one, which lights up and makes a sound. Any kind of a test equipment that you use, test each phase with a line tester.
Notice that the unit is mounted on the hot stick to maintain proper. Sent back down to the groundman, the auto-ranging voltage indicator is rechecked to confirm that it was operating properly. He again uses a separate tester to activate the auto-ranging voltage indicator. Notice how it sequences through a series of all display ranges, verifying its.
Okay, now he's wire brushing. We've already got that included.
Next, back down below the system neutral.
Okay, what we skip forward in the process right here is what the guy did on the ground. He installed the ground rod and the temporary ground, that's the ground rod itself, into the earth. What did he attach to the ground rod? Anybody remember? He installed the ground jumper. That was the yellow cable he installed on the temporary ground. And there's something very important here. What did he have to do to it before he sent it to the lineman?
Uncoil it.
Uncoil. Thank you. Uncoil. Okay. The next part of the process is what he's doing right now. What's he installing? What's it called?
Cinch, like a cinch chain.
Okay, it's called a ground cluster mount.
That's
Alright.
the thing with the chain, right?
Yep, that's the chain. It's a ground cluster mount. Now you got to be specific on location here. Where is it at? Above or below his feet? Supposed to be.
Below.
Below. Okay, it's got to be below your feet. So you can install it by hand where you're at. You see how close he is to the neutral. He installs it here, and they edit the video. Right, you need to install it right about down in here somewhere, so you're able to step above it and be able to work inside the zone above it. So, okay, install ground cluster mount above feet when installed. Okay.
Neutral. A grounding cluster bar attaches to the pole with a chain binder. A wheel tightener cinches the chain to secure the cluster bar in the best position. Now the free end of the cable attached to the ground rod comes up and is
Okay, so we've got the ground jumper. It's installed. Install ground jumper to mount. That's what he's doing right there.
clamped tight on the bar. Then another complete grounding cable set attaches to the cluster bar. With a grip ball clamp stick, he connects the other clamp of that set on the system neutral.
Okay, so he install ground jumper set to mount, and then he goes install ground to neutral. That's what he's doing in that process right there.
Now he'll finish connecting the next set from where he had hung it on the neutral in the place he cleaned earlier by wire brushing.
Okay, so installed ground jumper to neutral.
This grounding set now bridges from the neutral to an outside phase conductor.
Okay, and now he is install ground jumper to left phase.
Always clamping on the area cleaned by wire brushing.
Okay, install ground jumper set to left phase.
Next, he uses a third grounding set to connect the first phase to the center phase.
Okay. Install ground jumper to center phase. Okay. Install ground jumper set to center phase. And you can pretty much know and understand from what we did from the left phase to the center, what's he going to do next? Install ground jumper to right phase.
And finally, he completes the last link by connecting the center phase to the other outside phase conductor.
Okay, that's it. That's the installation and the steps for installation of grounding 3 phases from start to finish, and of grounding of a 3-phase line. Now, what you're also going to have to include here, and I know this is getting kind of long, what's the procedure for removal?
Go in the opposite direction.
Go in the opposite direction, but you got to make sure that you go in, this, you're working from what you can say outside in, and then when you go in removal, you're going to go from inside out. So what you don't want to do here, and I'll just show it on the video, you do not want to remove the center phase jumper from the right phase first. You want to do what? Remove right phase to center. That way you still have a grounded conductor here in your stick. So removal, remove right phase jumper, okay, remove jumper from center phase. So now you're taking down that one. All right, now it just continues on. Remove center phase jumper. All right, and then remove jumper from left phase. Oops. Move that down here. All right. Removed left phase jumper. Remove jumper from neutral. Remove neutral jumper to cluster. Remove jumper from cluster. Remove ground jumper from cluster and remove jumper from ground rod. There you go.
Chris Shoemaker, did you mean to do the thing for the left phase twice?
Let's see, left. Let's see what we got here. Remove right phase jumper. He's removing it. Remove jumper from the, that should be center phase. CNTER. Maybe not. I was typing pretty quick. All right, remove center phase jumper. And remove jumper from center phase. That's right. Remove left phase jumper. And remove that jumper from the neutral. That's correct. Remove the neutral jumper to the cluster. Or remove the jumper from the cluster. Neutral jumper to it. Yep. And remove the from the cluster. Remove the ground jumper from the cluster and remove the jumper from the ground rod to cluster. There you go. Okay. So it's just going to be a one question on the quiz, and the quiz is going to have, you have to include all these steps. What is the procedure for installing and removing a set of grounds on a three-phase line? So there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. 24 steps. Okay, don't forget to include these two. Wire brush all connection points included the ground jumper clamps and test each phase with a line tester. Let's see. Yep, got the above feet. Okay, any questions there? Obviously, you'd be able to go back in the video if you need assistance with it. Yes, sir, Paul?
You've got remove jumper from center phase twice. Is that correct?
Let's see, remove right phase jumper. He removes it. Remove the jumper from the center phase. He's got to take it off of here.
Okay.
Right, remove center phase jumper. He's got to remove that. And remove jumper from center phase, from left phase. That's what it should be.
Okay.
There you go. Thank you. I think that's what the other student had also said. All right, remove left phase jumper. He removes it.
All right.
And remove the jumper from the neutral. That's right. Remove jumper from the neutral. He's got that. And remove the jumper to the cluster. That takes care of that. Remove ground rod jumper. That's the one going down the ground rod. And remove the jumper from the ground rod to the cluster. That's the one at the earth. Okay.
You want to include remove cluster from the pole?
To make it an even 25, why not?
It's up to you.
Yeah, it makes it easy to grade.
Up to you.
Remove cluster from pole.
Sorry, everybody.
That's okay.
That's all. That's my bad.
All right. Remove cluster from pole. That makes it, that's pretty obvious.
Right.
All right. So there you go. That includes all the steps that are included right there. Okay. All right. Professor V and I both have to be at the college at 11 o'clock. So we've got about 15 more minutes here. And what I'm going to do is go ahead and get you guys to do some homework reading for me. So that'll be simple for you. What we're also going to need to do later on in a quiz is, I'm on page 5, and I'll just read it out to you, is know what the employer's responsibilities and the employee's responsibilities are as far as safety is concerned. So I'm at the top of page 5. An employer has a general duty to provide work in a workplace free from recognized hazards. So these are their responsibilities. You know me, I like to condense things a bit. You just saw it by that notepad document I made right there. You can condense these down to make them simple. So the employer has a general duty to provide a workplace free from recognized hazards. They've got to provide standard rules. Standards? Now, what do they mean by standards? What's the difference between standards and rules?
Expectations.
Part of that's expectations. Another part of it, when they talk of standards, and you'll see this when you go into an organizations, you've seen some of the drawings that I've handed you before, correct? Or posted up online? Like for the transformer and the cross arm and whatnot, the standards drawings, even the drawings that I gave you for the transformer banks. Those are considered to be called standard drawings, standards. And there's plenty of safety that's factored into those drawings as far as clearances and safe work practices. You just can't throw something together up there in the world, build it, and it be safe.
Basically say they were guidelines, basically.
Yeah, safety guidelines. There is, and to be honest with you, out there in the world, and this is some things, you know, some of these ideas and some of these standards that you see in drawings, both on the Duke system, pretty much all systems out there, an employee came up with an idea and said, can we build it in this way to make it a safer situation? Now you'll notice, and I'm going to go back just to this video right here. Okay. You see the guy, it's on the pole. Make this big. There you go. All right, as far as this construction is concerned, the construction itself of this pole, what's the difference between this type of construction and the construction that we're using out in the field? Pay attention to the top of the pole.
The center phase is on the cross arm instead of on the pole.
Right, right. So for a guy to get in here and actually have a little bit, I mean, it's not much, but it does make a difference to get a little bit more of clearance when you're working in this area, especially inside the bucket. We use a pole top pin and extend the center phase up a little bit higher. So that gives you a little bit more distance. All right, I know this is not the specification, it's pretty darn close, but it looks like it's a little bit high. Where's the neutral at? Right about here towards his kneecaps?
Yeah.
All right, the old framing method used to be that you came down, and this should be 96 inches from the cross arm is where the neutral is at, from the through bolt, 96 inches down. The old framing method was you came down 36 inches, and the neutral actually used to be right in here. Now, what's bad about that?
It's in your way.
It's in your way. You can't get a bucket in between it. All right. If you got a bucket underneath it, you couldn't get high enough to work on any of these outside phases. Say your bucket truck is set up over here. Right. Yeah. Two is, can I work on an energized line just one line at a time? Can I work on two conductors at a time? This is a
no.
This is a smart, fast rule. No, you cannot work even if there's two people in the bucket. You cannot work between two different potentials at any time. All right. One man in a bucket truck cannot work on this phase while another man is working on this phase. Well, what we wanted to do here is, well, let's take the neutral and just try to get it out of the picture, just in case we've got the boom of the truck laying on it, or we've got another employee that's close to it in the bucket truck while we're working. Let's get this neutral out of our way. Is it another path for electricity to flow?
Yes.
It is. So let's move it. So employees came out there and said, hey, we might have to go, instead of a 40-foot pole, we might have to go to a 45-foot pole, but for safety reasons, let's get this neutral down and away from our workers while they're working on energized conductors. So that gives a great understanding of, you as an employee have the right to speak up and change safety standards out there as far as construction is concerned. It went, when we proposed it, it went through really fast. Construction techniques changed really quick. Another thing that they liked about it is if you take this center phase and move it to the top of the pole, you've got more room to install switches. So your switches are not so close together. So it flew real well. Okay, so back to the book. You've got standards, you have rules, and you have regulations that apply to the work. An employer must also ensure that employees have, maintain, and use safe tools and equipment. All right, so they are the providers of your safety gear. What's that going to include? All of your PPE, correct?
Yes, sir.
All right, PPE is going to include your hard hat, your safety glasses, right? Your work gloves, your rubber gloves. Hold on one second. Get rid of the guard dog there. All right, where was I? So they got to provide safe tools and equipment. Now that doesn't mean that I can go, and get 5 pairs of gloves a week or 4 pairs of boots a month. As far as the boots are concerned, most utilities require that you buy the boot. They will offset the price for the steel toe and steel shank. And I think Santee Cooper was giving $45 per pair of boots. And those were payroll deducted out of your paycheck. Now, who provides the rubber gloves?
Santee Cooper.
Yeah, the company will provide you 2 sets of every voltage glove that you need. So one set is going to be with you and one set is going to be off for testing. So one set's in use, one set's off for testing. And you know from before, Santee Cooper provides their employees with a set of 20 kV gloves and a set of 40 kV gloves, depending on the voltage they're going to be working. So anybody think of anything else that the employer needs to provide to you as far as safety gear? One important thing.
A buck squeeze?
There you go. A buck squeeze and a flip line lanyard. Now it's your responsibility again to inspect it, to maintain it, to make sure that there's no problems with it. But as far as the buck squeeze and the flip line lanyard, they are required to give that to you. It is a piece of safety equipment.
Now, when you say inspect the buck squeeze, how do you know that it's starting to go downhill? Like, what's the actual?
When you start, and what they call it is called red threading. And it concerns the green part of your belt. I think I've got one in my truck. I'll show you. Once inside the weave of the green belt, they've got what they call red thread. And if it deteriorates enough or gets a cut in it, that red thread will poke out. And if you have any red thread showing, you've got to take that buck squeeze out of service. As far as the brown side lasts for ever.
Yeah, even if the brown side looks like it's shredded.
Yeah, I mean it's frayed and whatnot. That's no problem. I mean those things last to the end of eternity. Now, if you got a cut in it, like a gash in it or a cut in it, that has to be taken out of service. But wear and tear on the brown side, there's no problem there.
Damn fool.
Okay, good question. All right, an employer that sets up a safety management system will find it effective for managing many safety responsibilities required. Okay, an employer must inform employees of their rights and duties under the Employees Safety and Health Program and, of course, must not discriminate against employees who exercise their rights under a labor law. Employers have other duties, such as informing employees of the existence of their medical and exposure records Employees also must provide these records to employees upon request. Okay. So know the details of what needs to be included as far as the employer's responsibilities are. Now, the employee's safety responsibility and rights. Labor laws are written to protect employees, and employees shall become very familiar with occupational safety and health administration regulations, so that there is little doubt as to their responsibilities and rights. Okay. Has anybody ever seen an OSHA safety manual?
Yes, sir.
All right. How big is it? How many pages?
An OSHA safety manual?
Yes, sir. The full manual.
Oh, hundreds?
I think for everything in industry, it's right around 3,000.
Oh my God.
Okay. So as far as this book is concerned, you're going to have to study every single one of those pages to know and understand everything. Is that right? Cole, you're going to do that tomorrow, right?
Do
What's
what?
that, sir?
You're going to study that safety manual, know it by tomorrow, right?
Oh, no, that's what I'm trying to tell you. You know, I ain't gonna be able to
Guys.
do that. I can barely read as it is.
What we told our employees and advised our employees is, each company has a safety manual of its own, which is a condensed version, and it really narrows the focus down to utility. The utility work that goes on in the safety inside of utility is know that if you run into a situation or you have a situation of where you need to know what the safety procedure is, where to find it. Now, OSHA is fully online right now. So if you go to the OSHA website and you type in lifting with a crane in the OSHA website, it's just going to give you all of the regulations that are included in that. Working on energized circuits, it's going to give you all that information. The employee needs to know where to find it and get those answers. Don't study the entire book. That's going to take the rest of your life to do. In summary, employees are responsible for performing their job safely, complying with all occupational safety and health standards and rules, following their employer's safety and health program, following their supervisor's instructions, participating in required training classes, reporting any potential hazardous conditions to their supervisors, and wearing personal protective equipment when instructed. Employees also must report any job-related injury or illness to the employer and seek treatment promptly. We'll go into more of that later. An employee has legal rights and is entitled to protection for safety on the job. One such right is the employee is not allowed to be punished or discriminated against by the employer for such acts as complaining to the employer, union, or any government agency about job safety or health hazards. All right, so know those employees' responsibilities. There are a couple in there that are, that are really specific as to what you need. Reporting any potential hazardous conditions to their supervisors. Are you going to report every single hazardous condition that you see to your supervisor?
You're supposed to.
You're supposed to. If you see something that's potentially dangerous, I mean, a supervisor might look at it as, we've done this 5,000 times and this is 5,001. But if you see something potentially dangerous in it, let your supervisor know. It's not to say that he might explain to you, this is the safety procedure we're going to follow, but you still have the right to ask. Okay, don't be afraid to ask any employee. All right, here's a good one. Following their supervisor's instructions. Now, a supervisor is going to tell you, I need you to go climb that pole, and I need you to go change that insulator out. You don't need your rubber gloves. Well, what's your answer going to be?
Yes, I do.
Yeah, just say, hey, I've got the ground to ground rule. I'm going to go ahead and wear my rubber gloves, and I'm going to take care of it. Watch, and I'm just speaking for the entire gamut of all the supervisors that are out there in the world. There is no, and you won't get discriminated against. This is, when they talk safety with these companies, don't be afraid to ask the question of your supervisor, is this what you just told me to do? Is this 100% right? Is this safe of what I'm doing? Do I need to do X, Y, and Z before I do that? Because some of the supervisors, especially when you've been working with them for a good while, go change that insulator out in that pole, are making the assumption, well, he knows the ground to ground rule. He knows how to ground the structure with a cluster mount. I'm just going to let him have at it. Don't be afraid to ask what needs to be in place as far as safety is concerned when a supervisor gives you an instruction. Okay? They're going to be generic. You be specific if you have questions. All right. Any other thing that, and wearing personal protective equipment when instructed? Well, wear your personal protective equipment when not instructed. Pretty much when you step out into a job site, what are you going to put on? Hard hat.
Hard hat, safety glasses, gloves.
Boots.
Yeah.
Yeah, as soon as you step out of the truck, those are the basic items that you're going to need to have on to be have your personal protective equipment on. Now, if you're going into a situation where there's loud noise, you're going to include hearing protection, but it's not noisy yet. If you're going into what we talked about before, any of the rubber glove rules, you're going to put your rubber gloves on. That's your personal protective equipment once you meet one of the 4 rules. All right, so you're going to add as you go on as far as the safety situation requires. But as soon as you step on the ground and step out of that truck, hard hat, safety glasses, gloves, boots, you're working on the side of the road, put a vest on. So those are the basic things. Should I, as a supervisor, have to come to your truck, look in your truck door, okay, it's time for you to step out of the truck, put your hard hat on, put your gloves on, put your boots on, wear a vest? Is that my responsibility as a supervisor? Yes or no?
No.
No, it's not my responsibility. It's yours to have it on. Okay. So for homework, you guys today, because I need to leave here in just a moment, be familiar with the 2 first paragraphs in page 5. Read them closely and be in preparation to get asked the question, what are your employer's responsibilities in a list and what the employee's responsibility in a list are for safety? Any questions? Professor V did say, I'm sure he'll have enough because we're going in building 300. He will be bringing out the overhead line construction task list. So we'll have a copy for you out there at the field today for you guys to study and go over. And we will meet at the field at 12:30 if there are no further questions. All right, gentlemen.